Right, I wanted to do one more example with you just to give you a better feel for this cumulative density function. And I've picked a trig function just because we haven't had a whole lot of practice with trig functions. And we've got half sine x between 0 and pi and then 0 elsewhere. Okay, so the first thing we need to do is find f of x, capital F. It's our integral from 0 to x. We don't know what that x value is, and we're just going to say it's of t so that we can integrate it easily. And that's going to be our integral from 0 to x of half sine t dt. So f of x, remember the integral of sine x is negative cos x, so it becomes negative half cos of t from 0 to x. And when we substitute that in, we get negative a half cos x minus negative a half cos of 0. And of course cos of 0 is equal to 1, so we have negative a half cos x plus a half. And we can put that all over a single denominator and end up with 1 minus cos x over 2. So this is our cumulative distribution function. Okay, now let's have a look at the questions we've been asked. We need to find the probability of x being less than or equal to pi on 2. And we know from our definition of f of x that finding a probability less than or equal to is just going to be the value of that function at that point. So probability of x being less than or equal to pi on 2 is just going to be f at pi on 2. So that's going to be 1 minus cos of pi on 2 over 2. And of course cos of pi on 2 is 0. So our probability is just a half. All right. C, probability of x falling between pi on 4, it doesn't matter if it's less than or equal to or just less than, and 3 pi on 4. Now there's two ways we could do that. We could either use our probability density function and do the integration, okay, or we could use our cumulative distribution function. Either way, you're going to get exactly the same answer, and I wanted to show you that, okay. So the probability between pi on 4 and 3 pi on 4, so first with our PDF, let's make a little note there, it's just going to be our integral from pi on 4 to 3 pi on 4 of our function, so a half sine x dx, and that's going to be negative a half cos of x between pi on 4 and 3 pi on 4, and that gives me negative a half cos of 3 pi on 4 minus negative a half cos of pi on 4. And I've chosen this one to remind your brains, let's make a little note of it, going back to our trig, okay, that cos of 3 pi on 4 is equal to cos of pi minus pi on 4, which is equal to negative cos of pi on 4. We never lose our trig ratios and our unit circle work. Right? Never goes away. So that means we've actually got negative a half, and so cos of 3 pi on 4 is negative cos pi on 4, and cos of pi on 4 is of course 1 over root 2, so we've got negative 1 over root 2 minus negative a half times positive 1 over root 2, and that means we have 1 over 2 root 2 plus 1 over 2 root 2, and that gives me 1 over root 2, And of course we rationalize our denominator and we have root 2 on 2. If we were going to use our CDF, and I'm just doing this to show you that both of them would work, probability of x falling between pi and 4 and 3 pi and 4. Now remember, we have to do our larger one minus the smaller one, so probability of x being less than 3 pi and 4 minus the probability of x being less than pi and 4 is going to be our function at 3 pi and 4 minus the function at pi and 4. And that's going to be 1 minus cos of 3 pi and 4 over 2 minus 1 minus cos of pi and 4 over 2. And that's going to look like a far worse fraction than the other one. And when we simplify all of that out, we end up with 1 plus 1 over root 2 minus 1 plus 1 over root 2 over 2, and that's 2 over 2 root 2, which is exactly the same, 1 over root 2, which is root 2 on 2. Your choice which one you're wanting to use, unless they're specifying the method to use. Now the next one was also specifically chosen because it's a bit of conditional probability, and that's our probability of x being greater than pi on 4 given that x is less than 3 pi on 4. And for that you need to remember that the probability of A and B over the probability of B is equal to your probability of A given B. Alright? So that means that what we're actually looking for is the probability of x being greater than pi and 4 and less than 3 pi and 4 over the probability of x being less than 3 pi on 4. And we've already worked out what the probability is of x being greater than pi on 4 and less than 3 pi on 4. So we know already that that's root 2 on 2. And using our CDF, we can say over f of 3 pi on 4. So that's root 2 on 2 over 1 minus cos, what's your fractions? 3 pi on 4 over 2. And that's equal to root 2 on 2 over 1 minus negative 1 over root 2 on 2. And that gives me root 2 on 2 over root 2 plus 1 over root 2 all over 2. Stacked fractions, what a nightmare. Root 2 on 2 over root 2 plus 1 over 2 root 2. And then we can rationalize and we can sort it all out. Root 2 over 2 times 2 root 2 over root 2 plus 1. And that's going to be 2 over root 2 plus 1. And we're going to use our conjugate, so 2 minus 1, root 2 minus 1. And that gives me 2 root 2 minus 1. Not minus 1, minus 2. Okay, that was quite a mouthful, but I think it just gives you a bit more of an example of applications for this.